Day to each and everyone. My name is SHIEK, and for this video, I'll be presenting my output in Activity 6 entitled Titrations. So without further ado, let's begin. My objective in this video is to know what is titration and to know what are the steps for carrying out the titration. So what is titration? A titration is a process of chemical analysis in which the quantity of some constituents of a sample is determined by adding to the measured sample an exactly known quantity of another substance with which the desired constituents reacts in a definite known proportion. It is also defined as the process of determining the quantity of a substance A by adding measured increment of substance B, the titrant with which it reacts until exact chemical equivalence is achieved. A titration is a technique used to work the concentration of an unknown solution when you know the concentration of another solution. You carefully add the known solution to set volume of the unknown solutions until the reaction is complete. This enables you to work at the concentration of the unknown solution. You may need to use indicators to signal the end of the reaction. You can calculate the concentration of an acid or an outlier by carrying out a titration experiment. In this video, we're going to look how to carry. In the next video, we'll indicate the calculation to go with the experiment. The apparatus needed for the ratios look like this. The puppet is needed to accurately measure a certain volume of the unknown solutions into the flask. Titrate is then used to accurately measure and add the unknown reacts into the unknown until the action is complete. The burette can measure up to 0.05 cubic centimeter accuracy. To carry out the ratio, you follow these steps. 1. Using the pipette at the sieved volume of the unknown solution to a clean conical flask. 2. You may also need to add a few drops of indicator. 3. Full liberate with the unknown solution. 4. Record the starting volume on the burette. 5. Slowly add the solution from liberate to the unknown solution in the conical flask. 6. You may need to solve the flasks to mix or use a stir plate. 7. Stop adding when their action is complete, the end point is reached. This is very indicate a meal because there would be an appropriate color change. 8. Record the final volume. 9. Subtract the final volume from the initial reading. This gives you the volume of the solution added. This volume is called a titer. Turn for an accurate experiment. Make sure you beat the 6 frame a few times until you get consistent values for the titrant. Depending what indicating use will depend if the color changes gradual always sudden change. If you're carrying out an acid offal, I tried ratio, you may use an universal indicator which would give a gradual color change where litmus would give you a sudden patent change. Sometimes the acid may be the known solutions and the apply unknown, and other times that alkali the known and the acid an unknown. So if carried out the titration a few times and have a consistent to even titration calculation, now that you know that Asian what a second part of this video to see how to do educational population to work at the actual concentration of the unknown solution. All you really need to remember is that titration I used to work out the concentration of an unknown solutions when you know the concentration of another solution. Generalization. It is very important for us to know the titration because in chemistry, it allows for an accurate determination of solution concentration of the analyte. For instance, titration is an analytical method where a scientist can determine the unknown concentration or quantity of an analyte via the volumetric additions of titrant solution with a known concentration. The analyte and titrant react in a known stoichiometric relationship where at some point in the addition of titrant, the reaction will have consumed all of the analyte. The volume of titrant added and the molar stoichiometry thus allow for the determination of the unknown concentrations. So that's all for today's video. Thank you for watching.